What?
I didn't get that syllabus packet.
Okay. Because currently don't have any grades other than the bonus, which I haven't put in yet.
So do I just
Doing the questions on the back wall. Yes. And kind of just pointing out the calculator policy. Just so your parents know, don't think it will have to take effect, but if it did, they kind of seen it and understand it. Any questions over the homework?
Yes. Number 5.
From this one here?
Yes.
So from 1.2, number 5. So the function is f of x is equal to 5x minus 2. And we want to describe the transformation and identify the family in which it is with. Now the family would be linear. Now for this one here, we do have two main transformations. We have the 5 and we have the negative 2. We have the 5 and we have the negative 2. Okay. Now the 5 would be our vertical stretch. Because it's a stretch if it's greater than 1, it's a shrink if it's between 0 and 1. So since 5 is greater than 1, it would be a stretch. So it'd be a vertical stretch of 5. So this is the homework of 1.2. And the minus 2 tells us we're going either up or down because it's outside parentheses. And it would be?
Down.
How far?
2.
Down 2. And that's it.
So like odds on that.
Yes.
Help with 15.
15. Negative x squared. Now we don't have to identify the family which with this function is located or grouped with, but it would be quadratic if we did. Now the only transformation we have for this one here is the negative. Now that negative tells us we have a, now there's two places it could reflect. It's either going to be across the x or the y-axis. It is. For it to be across the y-axis, it would be to be inside the parentheses. Kind of like when we applied the transformations. If we applied a reflection across the x-axis, it was outside the function. Across the y is inside. 1.2 is what we looked at for these here.
So like after 15, whatever is it, 19?
Through it's 19 through 25 odd, and then 27, 28, 31.
27, 31.
Yes. Yes.
That's all?
Yeah.
What would you do? Wait, so on these you just write either down one or down something or up something?
Down something, up something, reflection,
Oh.
like whatever the transformation that's occurring. We're just naming it.
Number 13, it's just have to absolutely just put it down 5.
Since it's inside for 13, it would be left or right, because inside the parentheses, we're talking left or right. Outside parentheses, our absolute value is up or. Mhm.
So it'd be, it would be inside. Which side? It's inside what?
If it's inside, we're talking about our horizontal translation, our up and down. And when we applied it yesterday, it was our f of x minus
If
8.
it's outside what?
It would be
So the answer's horizontal.
it would be horizontal or really kind of left or right. Since it's negative, opposite of what we think, it would be right
Right,
5.
Where's this? That was 13.
Now, looking at today's lesson, we're continuing on. We'll do a few more of our reflections, and then we're going to look at our vertical stretch and shrink and horizontal stretch and shrink. Now, what we finished off yesterday was the reflection across the x-axis and reflection across the y-axis. And if we reflected something across the x-axis, we used the notation negative f of x and then applied that function there. If we reflected across the y-axis, we used f of negative x. Okay. Now, where we stopped off was this one here. Write a function g, whose graph is a reflection of the y-axis of the function of the graph of f, of this here. And if we reflect across the y-axis, the one we're using is f of negative x. So if we're reflecting this function across the y-axis, we're using f of negative x, this here. Which, as we saw yesterday, if we're doing this here, to apply it, we're just going to replace every x in the function f of x with negative x. So every time there's an x in the function, we replace it with negative x. So here, g of x, we have the absolute value. The x is now negative x, guys, minus 5, minus 4. Questions on this here so far? Now at this point here, guys, we can simplify a little bit, really just removing the parentheses and rewriting it back out. And that's our function. Possibly, we either did this one or we stopped here. Mm-hmm. It might have been the one above it. You should be either really hydrated or really have to use the bathroom. Questions on reflections? We feel good with reflections. Okay. So again, with any of these here, the biggest thing I would say is go back to this notation. Go back to these forms here. And start off with those there and plug it in as we have it, because that's going to really help us. We'll look at this last reflection here, and then we'll move on to our vertical stretch and shrink. Now, here, this function, we'll call it g of x, is going to be a reflection in the y-axis. So according to our kind of notation, a reflection in the y-axis, we're talking about what? F of negative x. So this is where I would start, f of negative x, because this is going to tell us how to change the function, how to apply this transformation to the function itself. Because if we're saying we're reflecting across the y-axis, we're replacing every x in the function with negative x. So if we look at f of x, in this case, there's only one place x shows up. It's behind the 1/2. So we'll still have the 1/2. But x is now negative x plus 1. Now, out of all the problems we've had so far, this is one of the few where we've actually had a variable not a variable, but a number in front of the variable? Quickly. So this one here, we have to multiply the two together. So what is 1/2 times negative x? So we have a positive times a negative would make it negative. So it's just negative, yes, x plus 1. That's it. Questions on any of this here? Now the next thing we're looking at is horizontal stretch and shrink and vertical stretch and shrink. Now our notation for horizontal stretch and shrink is going to be f of a times x, and vertical is a times f of x. So whenever we're told that there's a vertical stretch and shrink, we take whatever that value is, plug it in for a in our a times f of x, and then apply a similar thing to what we did for reflection across the x-axis. We'll multiply through the function and have our new function with the stretch or shrink. Horizontal is one we have to be careful with, because again, like we said with identifying our translations left and right, it's the opposite of what we think, because if it looks like it should go to the right, it's actually going to the left. And if it looks like it should be going to the left, it's actually going to the... And the same thing's true with horizontal stretch and shrink. As we said, if the number is greater than 1, it's a stretch. If it's less than 1, it's a shrink. With horizontal, it's almost the opposite. Because if it looks like it should be a stretch, it's actually a shrink. If it looks like it should be a shrink, it's actually a stretch. Because this factor that we stretch or shrink it is of 1 over a. So whatever it's saying that we stretch or shrink the function by, we have to flip it before we can plug it in. So if it said that it's a horizontal shrink of 1/2, what we're actually plugging in is 2. Or if it's a horizontal stretch by a factor of 3, what we're actually plugging in is 1/3. We have to flip it. And that's the only one we actually have to change something about it before we plug it in. Now the first one we want to look at with stretch or shrink is this one here. Write a function h whose graph is a vertical stretch of the graph of f by a factor of 2. Now if we talk about vertical stretch or shrink, and horizontal stretch and shrink, there's two forms. We have a times f of x and f of a times x. Which one do we want to use for this one here? Is a going to be inside the parentheses or in front of the function? In front. Vertical is our a times f of x. So for this one here, what is our value of a? Two, because how much are we stretching it by? We're stretching it by a factor of, so a is 2. Now, since we didn't mess with f of x, it's still just f of x, we can plug the function back in for it. So we have h of x is equal to 2, parentheses, absolute value of x minus 3 minus 5. Now, just like with the reflection across the x-axis, we do need to distribute this too. And just like with our negative, it's not going to multiply inside the absolute values. It's just going to be right out front of it. So we have 2 times the absolute value of x minus 3 minus 2 times 5 is 10. that's it. Any questions on this here so far? So for the most part, vertical stretch and shrink is acting similar to for reflection across the x-axis, but instead of multiplying by a -1, just the negative, we're multiplying by a number. That's the only real change. So we good with this here so far? And he's probably going to be lost because he missed that. No other reason, just because he's missing these problems. But we'll go over those here in a second. Now this one here, I do need you to change the note sheets, because this time we're writing a function g of x whose graph is a horizontal. We're actually going to do horizontal for these here. Because the only real trick, so horizontal shrink of the graph by a factor of 1/3. We have to change it because it's horizontal. Because it is a horizontal shrink by a factor of 1/3, but what we're actually plugging into the function is not 1/3, it would be what? Take a guess. So what do we think? It wouldn't be 1/3, it would be what? So we're on this problem here. So we're doing the graph is going to be a horizontal shrink by a factor of 1/3. But it wouldn't be 1/3. We'd have to flip it, which would be 3/1 or just 3. Because when we talk about horizontal stretch or shrink, whatever the factor it is by, we have to flip it. This is the only one out of all of our transformations that we actually have to change something. Because the only other one that we have is horizontal, moving it left or right. But just by plugging in what the movement is, it changes it on its own. This one's the only one we have to do before we plug it in. And since it is horizontal, we're talking about f of a times x. Now, we know what our value of a is. The value of a is not 1/3, it is what? 3. So we replace a with 3. And just like with our reflection across the y-axis where we replace every x with negative x, here we're going to replace every x with not negative x, but 3x. Because we have f of 3x, so we're replacing every x with 3x. So, well, luckily there's only one x in the function, so we replace that one spot with 3x minus 3 minus 5. And no, we don't have to graph them. So our final function, if we simplify, is going to be 3x minus 3 minus 5. Questions on this here so far? So horizontal stretch and shrink, it's not that they're tricky in them of themselves, it's just remembering to flip it, flip that scale, flip whatever factor we are scaling it by. And realistically, when we talk about horizontal stretch and shrink, it means along the x-axis, the function is increasing faster. Or if it's a shrink, it's increasing slower. Questions on this here? Are you ready for the next one? Write a function g, so g of x, whose graph is a horizontal stretch of the graph of f by a factor of 5. So you'll need to change the notes again for this one. since it's horizontal, we have to change this from 5 to what? We have to change it from 5 to, goes on the floor, because again, we've got to flip it. So what would be the flip of 5? So that would be the opposite. So not so much that, but 1 over 5, the reciprocal. Yeah, because we don't want to change positive, negative, but we want to change the fraction. We want to flip the fraction. I think I should have phrased that better. So we're really talking about this as 1 over 5. So we're looking at the reciprocal. So the value of A for this here is going to be 1/5. And again, just like the last one, if we're talking about a horizontal stretch or shrink, we're talking about f of A times x. Now that we have that, we know that our value of A is 1/5. Questions on this so far? Now at this point here, we do plug in 1/5 x for every x in the function f of x. We'd have absolute values of 1/5 x minus 1 plus 2. So we replace the x in f of x with 1/5 x. And at this point, we can drop the parentheses and just say g of x is equal to the absolute value of 1/5 times x minus 1 plus 2. Any questions on any of this here? We're ready for the next one. Because it might be good to see at least one more vertical. Because there's only one thing after that in doing combinations of these. Doing more than one transformation at once. Now this one here, we want to write a function h whose graph is a vertical shrink of the graph by a factor of 0.25. Now since we're talking about a vertical stretch or shrink, we have a times f of x. Vertical stretch or shrink is exactly as we see it. We don't have to do anything to change it. So this time our value of a is what? What did it say the factor was? 0.25. So our value of a is 0.25. 0.25. Now we didn't do anything with f of x, so we can just replace it with its function. So we'll just replace f of x with what it's equal to. Focus up here. The absolute value of x minus 1 plus 2. So we replace a with its value, then we replace f of x with its function. Now we just need to simplify. So we're going to multiply through by our 0.25. Now multiplying the absolute value by 0.25 just gives us 0.25 times the absolute value of x minus 1. Now we need to multiply 0.25 by 2. We can do this by hand or we could do it in a calculator. Either one will work. Yes. Quickly. So if we do 0.25 times 2, we get 0.5. And that's our final answer. questions on any of this here? We ready for the next part? I'm going to skip ahead to this one here. Combinations or combining transformations. Combining transformations is a lot if you try to do it all at once. The big thing I would say is do it one transformation at a time in the order in which they are listed. Do it one transformation at a time in the order in which they're listed. So if we read through this here, let G be a vertical shrink by a factor of 0.25, followed by a translation 3 units up of f of x equals x. So the first thing it asked or told us to do or apply was a vertical shrink of 0.25, then 3 units up. Now we're going to call the in-between step something different than G. We'll call it H. So I'm going to start off with H of x. We'll use G of x next. So what are we doing to our function first? We're taking a vertical shrink. So if we look at all of our notations, for vertical shrink or stretch, it is a times f of x. Because again, the function we're applying this to is f of x. Now for this here, what is our value of a? What is the value of the stretch or shrink? 0.25. So we'll replace a with 0.25. Any questions on how we found the value of a? Yep. Now at this point here, we can replug in f of x's function. Well, what is the function for f of x? Well, f of x is equal to, so we're just going to plug in x. And if h of x is equal to 0.25 x. Guys, focus in. Any questions on how we applied the first transformation? Now, we have a second transformation, a translation of 3 units up. And when we talked about these originally up and down, our vertical translations, we used f of x plus k. Now our final function, they want it to be called g of x. I'm not going to be a real nitpick on if you have it as the final answer written as g of x, h of x, q of x. It'll just need to be one of them. But this 3 units up, we're not applying to this f of x equals x anymore. We're applying it to our h of x. So really we're saying g of x is equal to h of x plus k. Because f of x is just a placeholder telling us which function we're applying it to. This time we're applying it to h of x, not f of x. But how far are we moving it up or down? We're moving it what? Units up. So it would be plus 3. The value of k is positive 3, so we can say plus 3. We still have our h of x. Now, what is our function h of x? It is our 0.25x. So we can replace h of x with 0.25x. Now, since there's nothing being multiplied in front of h of x, we can drop the parentheses, giving us this here. Are there any like terms between our 0.25x and 3? Guys? No? So that right there is our final answer. Any questions on any of this here? So again, with these combinations or combining transformations, really all we're doing is just one transformation at a time. We're just doing more than one of them with each function. Any questions on this here? Let's look at the next one. This one here, let G be a translation of 6 units down followed by a reflection in the x-axis of this graph. So we're going to write it as G, so we'll need an in-between step. So we can call it H of x. 6 units down. So if we're going up and down, we're talking about vertical. Vertical translation is our up or down. So since our starting function is f, so we can say f of x plus k. That's where we'll start, is with f of x plus k. Now we need to determine what our value of k is. How far are we going up or down? We're going up or down by a factor of? Would it be positive or negative? Negative. Because it's going down. So we'll replace k with -6. So we could have said plus -6, but minus -6 works as well. Now what is our function f of x? F of x is just the absolute value of x. So we replace f of x with the absolute value of x. Now we can put this in parentheses like we've been doing, which will end up just being removed, telling us that we have the absolute value of x minus 6. Any questions on this here so far? Now we do have another transformation. We need to reflect it across the x-axis. Now our normal notation, the way we have it written for across the x-axis, is our negative f of x, but we're applying it to which function? H of x. So we're just saying negative h of x. While our h of x function, the function we're applying this to, is the absolute value of x minus 6. Any questions on this here so far before we finish this problem out? So the last thing we need to do is distribute the negative between these two here. If we multiply the negative by the absolute value, we get negative absolute value of x. And the negative multiplied by the -6 would give us a 6. Telling us that our final function with these two transformations is negative absolute value of x plus 6. Any questions on any of this here? Any questions over anything we've done so far today? Okay. We have a few minutes left. Yes. Go on and give the first few a try. If you do have questions, please let me know. I will come around and answer them. Okay, work on that one.